This is my daughter's spinning wheel. We got her on the weekend for next to nothing, and it's probably in the neighborhood of 100 years old. And the interesting part about a spinning wheel is that pretty much everything about it has to do with law of the levers or friction. So we have this main wheel here, which is about almost 1 meter across, and as it turns, it causes these pulleys to turn at a much more accelerated rate. The outer sort of wishbone thing here is called the flyer. But what's very fascinating is the two pulleys are different diameters. So there's a huge mechanical advantage here, like probably 50 to 60 to 1. So that little one really spools up when you spin the big wheel. But the interesting part, this inner spool is on a separate pulley, and it rotates slightly slower than this flyer. So this guy here, the bobbin, gathers up the fibers at a slower pace. Now, obviously, when you buy something like this for $30 on Kijiji or $40, it sat in someone's house for a long time. So I had to do the first draft of cleanup on this machine. And step number 1, this bobbin didn't turn. So this little guy here was sticking and just tracking the outer one. And the idea is the outer one spins faster to wind up the thread. And the other problem was any thread, you see the blue here, was just spinning loose on the bobbin's axis. So I had to fix two things. First of all, I took a drill. I have a really long drill bit that I use once every 10 years, and it fit perfectly, and I reamed out like a century of dried oil and muck in there, and that got the bobbin traveling much more freely on this mechanism here. It's free to turn. The second problem was to address the fact that the thread would just slip on the smooth finish of the bobbin's axis. Rather than do something destructive like put a hole through it, glue sandpaper down, I increased the coefficient of friction by wrapping the bobbin in this rough twine, and that's provided enough friction that the thread wouldn't slip anymore and it began to get gathered. But the third problem showed up with these pulleys. What was on there was just old cord, and a lot of people seem to use this stuff, twine, and I found there wasn't enough friction and the pulleys here were slipping. So if the operator pulled on this, instead of it winding on the bobbin's pulley, these cords would just slip. So I switched to something I know is a bit more durable in that thing, and we switched to rawhide. Yeah, not cheap, still about 15 bucks, but the rawhide really does a good job of engaging those pulleys, and suddenly the machine began to spool up and collect the fiber like it should. But the last part was this tension adjuster right here. If you want to tighten or loosen, you bend this down or you pull it back. But like a lot of, again, just friction fit, it slips. So it has a tendency to slip forward and suddenly loosen the drive belt and throw the parts off. So the last thing I've got to do is I can tighten up this this grip here, this U-bolt, to make this a little bit firmer. But I could drill small little dowels so my daughter could just put in a wedge. I'd still rather not touch it, so I'm probably going to make a board that goes through here so she can put it up, shove the board through. So the whole machine is friction-based, and that makes it quite a little adventure in fine-tuning everything. And the other part you may not realize is thread itself holds together by friction. So this entire antique machine is operating on two principles: laws of levers and friction. And there's one last thing I need to fix, which will take a little bit longer. These posts holding the trunnions, this one is loose, right? And it's rocking in its socket. And what's on the other side is a wedge driven into the socket. So once again, friction.